Hello 108 students, Mr. McHugh back here with you on section 3.3. Hey, we've been working hard on here. We're going to tackle page 5 of our class notes here, and we are going to go ahead and handle a situation here now of what if you were given one specific point anywhere out on a Cartesian coordinate grid, and we labeled it generically as A comma B, and we ask write a vertical line and write a horizontal line for that equation. What I try to do side by side is a lot of times when you see these formulas and lawyerese writing in the book, it's a lot easier just to look at an example. So I picked 4 comma 3 to represent A comma B. And if I asked you, and let's just go over here and work with this way here for now, 4 comma 3, write a line that is horizontal and goes through the point 4 comma 3. Okay, now what I would do is I'd find 4 comma 3, I would draw a line horizontal, and I would ask myself, where does it cross the y-axis? And it crosses it at y equals 3, and you'd be done. That's all you have to do. Take what they give you, take the ordered pair, draw a horizontal line, and ask yourself, where does it cross the axis? And that statement right there applies for both horizontal and vertical. Where does it cross it at? Y equals 3, and you are done. Thus, you could say the horizontal line is the equation, y is your variable, b is a constant, is a number. Okay, you got to realize when they're writing these formulas down, which ones are real variables and which ones are constants, and that's half the battle when you study these in the book. Okay, let's go back to this one. Take 4 comma 3, write the equation of a line that is vertical and goes through the point. Well, I'd write 4 comma 3, vertical means up and down, and I would say, where does it cross the x-axis? It crosses it at 4. X equals 4, and you are done. That's all you have to do on those. Okay, let's tackle perpendicular and parallel lines here. I think in my notes before I forgot to mention, when you see little L1 and L2, we're talking about lines. These are just a generic line, a name for them. Now, of course, a line has got an equation, ax plus by equals c, or y equals mx plus b, but in general, you could label it just a generic little L for line 1 or L2. And if you see 2 lines going up and down and never touching, that represents parallel. And so if 2 lines are parallel, then we've already discovered that we know the slopes are the same. Okay, this is a little bit of a review. However, if 2 lines are perpendicular and the symbol with the upside down T means perpendicular, that means if 2 lines cross, they form, sorry, that's supposed to be 90 degrees. That's supposed to be an X there. Then the slope and the opposite reciprocal, remember that? Multiply together, the slope and its opposite reciprocal multiplied together equal -1. Okay, now with that said, they're going to give us some problems here where they are going to give us a point, -4 comma 5, and they're going to give us a linear equation. They're going to give us that basic information and challenge us and say, can you write the equation of a line, that is parallel through the point -4 comma 5, and it's parallel to the line 2x plus 3y equals 6. Okay, now you think about that for a second and you're like, wow, what do I do here? What can I get going? They say parallel. You know the slope has to be the same. The new line that you are going to write and the one they give you, they have to have the same slope. So could you find the slope of the given line? And the answer is yes. Isolate the y again. Remember that? So minus 2x on both sides, and then divide by 3, the coefficient in front of the y, and voila. Let me just squeeze this in here. And voila, you're given the golden form. Look how powerful this is. Just like that. 2 easy algebraic steps. Move the x term over, divide by the y coefficient. You get it every time. Y equals -2/3 x plus 2. So y equals -2/3 x plus 2. Okay, so if we want a slope that's parallel to it, we found it. M equals -2/3. Okay, that's half the battle. Now I chose to go back to method 1. You could use method 2 from before, but I'll stick with the way I did it here. Could I figure out the equation of a line given a slope and a specific point, x sub 1 comma y sub 1? And the answer is yes. You could use the point slope formula. Also, by the way, class, I forgot to tell you, I call that the working formula. Working because it's an intermediate step. Think of it like an access ramp onto the interstate that allows you to get on there and ultimately write your equation in y equals mx plus b or standard. We hardly ever write the answers just where you substitute in and stop. So I will turn around, take advantage of that. I know the slope is negative 2/3. I know y sub 1 is a positive 5. There's the minus, comes from the formula. And x is your variable, y is your variable, minus, don't forget that, and x coordinate is negative 4. Watch these signs, watch the negative, because the negative times the negative turns it into a positive. Watch these little details. Okay, now can we write this in y equals mx plus b? Next step is to go ahead and use the distributive property. So I got y minus 5 equals negative 2/3 x. Now negative 2/3 times 4 is negative 8/3. Okay, now got to isolate the y. So add 5 to both sides. There you go. Y equals negative 2/3 x. Now, does that make sense? Wasn't that supposed to be the parallel line? It's supposed to be the slope that we found from the first line. So that's good. We didn't lose it. And you take negative 8/3 plus 5, you'll come up with 2 1/3. Okay, now if you used method B, you would have taken y equals mx plus b, and for y you would have put the specific point of 5, or excuse me, the y coordinate, which is 5, the slope, which is negative 2/3, x happens to be negative 4 plus b, and when you solve for b you would have gotten 2 1/3. And if you go that way, which I do recommend, then you could have turned around and wrote y equals negative 2/3 x plus 2/3, because you've got the slope, you got the y-intercept. Okay, Mr. McHugh, I'm going to say sayonara for now. I'm trying to learn all my languages, and goodbye. I only have a few of them. We got to do one more page, so I will see you for page 6 to wrap up section 3.3. Okay, bye.